ce serait le temps de finir un peu, puis comme ça, tu as un peu de temps de questions. Hello, hello. Okay, good afternoon. Welcome back. I hope you all enjoyed both the lunch and the exhibition for those who managed to go. It is my pleasure to introduce this afternoon's session, and I would like to present to you our next speaker. It is Alexi Bern. He's a local here. He's a professor at EPFL. He's the head of the Environmental Remote Sensing Lab. He's also our neighbor. So we're very pleased to actually work with you closer once. His work focuses on mountain regions, and he does a lot of work also in Antarctica. And one of his latest acquisitions is a very big project, ERC Synergy grant called AVACA, Atmospheric Water Cycle over Antarctica, Past, Present, and Future. So we hope to hear a little bit about that as well. He will talk to us about clouds, precipitation in Antarctica, and also making the link to the technological component of his work. So the floor is yours.
Thank you, Danielle, very much for the kind introduction and the opportunity to present some of my work and give you some perspectives about this topic of clouds and precipitation in Antarctica. I would like first to acknowledge some of the co-authors and collaborators. Close the mic. Okay, sorry. Who are listed here and many others. So for those of you who may not be familiar with Antarctica, what are we talking about? It's a continent much close to the South Pole, mostly above 70 degrees south in latitude. There's an ice cap of about 2.4 kilometer depth on average, and it's the coldest, windiest, and driest continent on Earth. A very nice place to be. Cloud and precipitation. So why are we interested in cloud in this region? Clouds have a direct influence on the radiative budget of the atmosphere and the surface, and they're precursor of precipitation. So this is kind of a general interest for clouds. And I would like to spend 1 minute on a certain type of clouds called the mixed phase clouds, where mixed phase because you have the coexistence at below freezing temperature of both liquid water and ice, which thermodynamically is not stable, but we have a lot of those clouds. And of course, having supercool liquid water layers in the cloud has some importance. It's a key ingredient for the microphysical processes. With and without supercool liquid water, you have different processes taking place. They are also critical for melting events. Preconditioning the ice cap for melting, mixed phase clouds plays a strong role in this preconditioning. And finally, there's also, in all models, a strong radiative bias over the Southern Ocean. And mixed phase clouds are an important factor in these problems that the models have. Talking about precipitation, again, why do we care? It's far, there's nobody there. First, precipitation on the Antarctic continent falls almost exclusively as snowfall. There's a bit more rain on the peninsula, which is a bit special in Antarctica, but on all the continent, it's mostly snowfall, so solid precipitation. And because of the extreme conditions and the very limited number of stations and scientists who can go on site, precipitation is poorly understood. There's many things that we do not know. Moisture sources, the main processes, simply how much precipitation is falling is a big unknown. And it's very important because precipitation is a key positive term in the surface mass balance. The precipitation increase the mass, the melt and the sublimation decrease, and then you form ice, and then by calving and releasing ice to the ocean, that's the ice sheet mass balance. And this is very important because that has a direct influence on the sea level rise. Depending on this mass balance of the ice sheet, the sea level will more or less rise. So although it's far, we are all concerned somehow by what's happening over there. Challenges, I was mentioning, why is it so difficult to go there? Extreme environment. The minimum measured temperature was in Vostok in the 80s, minus 89.2 degrees centigrade. It's pretty cold. Winds, not in the interior, but on the coast, you have fierce katabatic winds. And at Dumont-Durville, for instance, one of the most exposed stations, the record is above 300 kilometers per hour. And then the anemometer went away with the wind. Tough conditions. Limited number of stations, especially in the interior. You only have a few where you have permanently people. So only a few places where you can go to deploy instruments and collect measurements. And mostly these measurements take place during the summer season where you can access the continent. So somehow we have an incomplete view of what's happening for the clouds and the precipitation because of these difficult conditions for monitoring these processes. It's not all dark. We have recent progress in remote sensing, and especially in space remote sensing. Having sensors and satellites that overfly the continent brings a lot of information. And in general, the recent technological progress open new opportunities. And here I just show a map of the first, if not climatology, but at least multi-year statistics about precipitation estimated using the CloudSat radar. Before this map in 2014, it was only based on model estimation. And so remote sensing is particularly well suited for Antarctica because of these difficult conditions and because we are interested not only what's happening at the surface, but also what's happening in the tropospheric column. So after this brief introduction about the context in which this phenomena takes place and where we want to work, I'll spend a few minutes on the mixed phase clouds over the Southern Ocean, taking a case study to see the limitation of the model and what observations can help us to decipher in these complex processes. Similarly, for a precipitation case study on the coast at the Davis station. And finally, more perspective and opportunities beyond one place, one season, where I will mention recent projects and what Daniel mentioned, this Awaka project that is just starting a month ago. So unfortunately, I don't have any results to present yet, but I can give you an idea of what are our objectives and the challenges. And finally, some conclusion. So, mixed phase clouds over the Southern Ocean. Here we will use data from the Marcus campaign. So there were different instruments on the Aurora Australis, the Australian icebreaker that do the legs between Australia and the Australian stations. And during this Marcus campaign, there were a number of instruments, among which, of interest for us now, a W-band Doppler radar, so a cloud radar, a cloud able to see in all the tropospheric column the cloud particles, a LiDAR that will be used to see supercool liquid water, and a microwave radiometer to have an integrated view, and finally aerosol measurements. And so this took place during the season 17-18. We'll focus on this case study, 14 to 16 February 2018. And we had mixed phase clouds and precipitation associated with a warm front. It was near the Mawson station on the coast. So you have the radar measurements here. And basically, this first panel here is the reflectivity. So the redder or purple or the color is, the more intense precipitation or the more cloud particles we have. And that gives you an idea about the vertical extension and the time evolution. Sorry, I forgot to mention, this is the time in the y-axis, and this is the height in the y-axis and the time in the x-axis. The second panel is about the vertical velocity, so a combination of the fall terminal velocity of the particles and the vertical wind. There's always wind in the atmosphere. And finally, the spectral width we'll consider it as a proxy for turbulence in this case. So we have a lot of information from the radar, and the LiDAR, you may see these black contours here, and these are the regions where supercool liquid water was identified using the LiDAR. Okay, so again, supercool liquid water means liquid droplets at much colder temperature than the 0 Celsius. It should be noted that during precipitation, so mostly this part, the LiDAR is completely blind, it's attenuated, it's too much falling. And this gap, this gap here is the radar stopped working. So this is the case. So we have mixed phase clouds here and here associated to this front. And the question is, we want to check is, can models properly reproduce these clouds? Okay, the weather or climate models, are they able to reproduce such cloud systems? To investigate that, we use the WRF model, Weather Research and Forecasting, which is state-of-the-art model. We use this one, but the conclusions we have here are valid for all models in general, the one that are at least used in operational context. So, 3 kilometer horizontal resolution, 250 meter vertical resolution, some information about the microphysical schemes, and we use a radar operator to be able to directly compare the radar measurements with the model output. That's why on this figure here we have the observation and the model simulation in the same variable, the same quantity if you want. So we can do this direct comparison. And what we see is that the timing is more or less okay, the intensity, the vertical extent, the model is doing pretty well. Now, if we look at supercooled liquid water, again, these black contours are what was detected by the LiDAR. We have here these contours somewhere down in the cloud, but the model does not do any supercooled liquid water in the upper part of the cloud. So we have a problem at the cloud top. And we checked different vertical resolution, some full speed and deposition parameterization, and we could play with many things. Nothing was able to produce this liquid water we saw at the top of the cloud. So clouds have, models have a problem to reproduce these clouds. Aside from the radar measurements and the atmospheric measurements, there were aerosol measurements. And thanks to Paul Demotte's group and their effort during this campaign, there were measurements about ice nucleating particles, INPs, which are important particles on which ice can deposit from the water vapor phase. And we checked using back trajectories that what was measured at the boat altitude was more or less representative of what we can expect at mid-level cloud altitude. And these measurements are presented here, and the important point here is that you see that the measurements, they are several orders of magnitude below the standard parameterization that are used. So when you use a model with a standard parameterization, you assume you have this concentration in INPs. And so for this study, we use this empirical fit, so this orange line, as a parameterization for these INPs in the model. And when we do so, suddenly the picture is changing drastically. So you have again the control, the observation, the control simulation, and now when we add this new parameterization, we see liquid water appearing in many places in the cloud. So we have a much better agreement with the observation, and this shows that this ice nucleating particle on the parameterization in the model is critical to be able to reproduce these type of clouds over in the region of interest. So here the main point is that we know that models have difficulties in reproducing these type of clouds over the Southern Ocean. Using different remote sensing instruments and in situ measurements for aerosol, we can show that we are able to derive relevant information to characterize the cloud and to evaluate the model and their capabilities. And we can also evaluate where the problem is coming from in the model. So for this case and this region, the INP parameterization is a crucial factor. You can play on many other things, but this one, if you don't get it right, you will not be able to simulate these mixed phase clouds, which have a strong influence on the radiative budget and so on. Moving to precipitation now, at the coast. So I will use again a case study from a campaign that took place at Davis Station on the Antarctic coast, East Antarctic coast. 1819 the campaign was, and you have a picture here. So Davis is here. You have different instruments, and again we have different radars at different frequencies, this one and this one. And we will use their data to investigate what's happening during this 8 to 10 January 19 precipitation case. Let's first have a look at the general situation, large scale. If we look at the large scale, so Davis is here on the coast, so north is up. And if we look at the pressure map, we have a low pressure system here that advex moisture and the wind from the northeast to Davis. If we add the temperature information, and this is the potential temperature, we see that we have a warm front just about arriving at Davis in this case. And we have a cold air pool on the Pritz Bay here, deflecting the wind because of this cold and dense air over this area. And if we add the information about humidity, what we see is that, without going too much into the details, we have this kind of long, elongated, very moist and warm air. So basically, this low-pressure system is pushing warm and moist air towards the coast. So we have all the ingredients for an atmospheric river, and in these conditions, usually you can expect to have a lot of precipitation, even extreme precipitation, in the landfall of this atmospheric river. So in this case, we could expect a lot of precipitation at Davis, and we'll see that it's a bit more complicated than that. So if we look at the situation over Davis, here again we have this time and altitude diagrams from different radars. And if we look at this first panel over the 3 days, we distinguish 3 phases. The first one here, where we have the incoming front, something which looks like precipitation, but you also see that nothing is really reaching the ground. There's something strange happening at low level. Suddenly we don't have any more cloud or precipitation. A second phase where we have a bit more precipitation reaching the ground, but nothing super intense. And a third phase where we have a lot of sublimation in the lower layer. I will focus mostly on phase 1 because we don't have the time to go too much into the details. But yeah, please note that we have a lot of sublimation in these 2 phases. We also, thanks to this vertical velocity, we can see that we have a lot of turbulence in the lowest layer. This attenuation of red and blue colors mean that we have the eddies, and that's what you see in this panel. And finally here, taking advantage of the polarimetric capabilities, we can have an idea of what type of hydrometeors, what are the particles that are up there. And on this diagram, you can see that we mostly have crystals. The greenish color corresponds to a dominant crystal type. And the reddish orange means that we have a lot of aggregation. So aggregation means crystals stick together to form bigger particle. And that's an important microphysical processes because that's how you have bigger particles falling faster. So you increase your precipitation rate. And this is confirmed by the dual frequency ratio, but I will not go in this way. So we have 2 main aggregation phases in phase 1 and phase 3. And again, we'll focus on phase 1. So now the idea is what's happening. We want to understand, because from a conceptual point of view, it's very difficult. We have all the ingredients, a lot of water, we know we should have a lot of snowfall, and then at the ground we see nothing. So what's happening? To understand the situation, we have to look at not only the local scale of our measurements, but also at a broader region. So you have here a horizontal cross-section in the model simulated vertical wind. So Davis is here. And what we see is that we have a lot of downdraft, blue color, so the wind is going down. And suddenly a very strong updraft. This dark red color means something is going up very, very strongly. And this is confirmed in this vertical cross-section where you see the downdraft and this strong updraft. If we add the potential temperature, we see that the warm front here is associated with large-scale lifting. But more importantly, at the local scale, we see orographic waves that are generated by this hydraulic jump here down this is the ice, basically the topography. And we have this strong hydraulic jump generating waves, this alternation of red and blue, it's waves, and we have a slightly stable layer trapping these waves in this layer. And from the precipitation point of view, what is important here is that we have this föhn wind formed by there. So we have the wind going down and the temperature, the isentropic drawdown, the hydraulic jump, and if we add the relative humidity information, these green contours here, we see that we have a very dry tongue extending from the hydraulic jump place to about 40, 50 kilometers. And Davis being here, you see that this dry air is completely sublimating all precipitation falling in this area. So you have precipitation before and after, but locally here, there's nothing falling because everything is sublimating in the air. And this is confirmed when we look at local radar measurements, where we see the cloud and precipitation forming at the upper part, falling, growing, and suddenly entering this layer where we have a lot of turbulence and dry, and you see that the signal is decreasing and eventually completely disappearing. So here, the main message is that we have large-scale conditions favorable for intense precipitation, okay, in the Davis region, but on the ground, we barely see anything. So there's something strong happening. And we see that interactions between the synoptic flows, the large-scale conditions, and the local terrain leads to the formation of orographic waves and fun winds that have strong influence. The orographic waves, because of the updraft and turbulence, they impact these aggregation processes, so they have an impact on the microphysical processes taking place. And the fun winds, they have a strong impact because they create this dry layer and you completely sublimate the snowfall. So the main message here is that small-scale processes may overturn large-scale conditions. Despite having all the ingredients to have extreme precipitation, in some places you have nothing because of the local conditions. And here it means that you cannot only focus on the large scale if you want to have cloud and precipitation correct, at least at the local scale. So these example and case studies I showed were traditional one campaign, one place measurements. And now, in a more prospective way, I think we have to go beyond that, beyond one place and beyond one season. I would like to give two examples in this direction. The first one is the Pope campaign. The name stands for Princess Elizabeth Orographic Precipitation Experiment. That was 1920. This took place in the Princess Elizabeth Station, which is a bit inland, and most importantly, is really in the middle of many mountains, so complex terrain. Antarctica, but also complex terrain. We had the campaign there, joint effort with our colleagues from Cryos, so another lab at EPFL. And the idea here was for us to monitor and characterize orographic clouds and precipitation. I won't give an overview of all the aspects, but one thing I would like to mention is this micro radar transect that we try to build. The MRR is a low power, robust, simple profiler, so it could run on solar batteries and be outside. And you have this map, so the station is here, you have this mountain range here, and our wheel was in order to study how the flow is impacting the mountain and what does that imply for clouds and precipitation. We wanted to have a kind of transect. So one point sampling somehow upstream before the mountain, before the flow impedes the mountain, in the mountain and, downstream the mountains. Once the mountain is passed and you start to be on the high plateau. And I mentioned that because that's a first very preliminary, very simple effort to have a transect. So not only one place, but distributed measurements with rather complex instruments. And I also mentioned that because SPI was helping us financially for this, both myself and Alfonso, the student. And very quickly, just one example of the measurements. So you see we have some similarities in the timing and the features, the general features, but also some differences. We see much more sublimation in the one upstream, in the valley one, because of these katabatic winds and so on. And we see also some intensification periods that we do not see in the other. So very preliminary, we still have to work on that, but with this type of distributed measurements, we can really try to investigate the interaction between flow, cloud precipitation, and the complex terrain. Now, to conclude, AWACA was mentioned before. It stands for Atmospheric Water Cycle over Antarctica, past, present, and future. As Daniel said, it's a project that is supported by an ERC synergy. There are different PIs, Thomas Dubos, Christophe Janton, Valérie Masson, and myself. And not a PI, but a very important body in this project is IPEV, the French Polar Institute, Jerome will explain us a bit more later on. And this is a critical partner because if you want to work in Antarctica, you need to have the logistical means to bring your instrument, to host you there, to help you have the power and everything. So in general, the objectives are to have to gain an in-depth understanding of atmospheric branch of the water cycle over Antarctica. And to do that, we will combine observation and modeling tools of the process driving the moisture fluxes from the coast to the interior. What's happening to the moisture advected from the ocean to the interior. Of course, the project started a month ago, so I have not much to show, but at least I can explain you our vision and what we plan to do in terms of observation here. So this is Antarctica, and this is the transect that we want to equip. So we want to have 5 sampling locations, the 2 end stations, Dumont d'Urville at the coast and Concordia on the high plateau. And this transect is crossing a very diverse type of climate. And the coast is mild but very windy, and the interior is not that windy but extremely cold and dry. And the idea is to follow basically, because this transect is aligned with the typical moisture pathway. So we will sample the atmosphere along this transect to see how things evolve. And the goal is to build a continuous multi-year meteorological, isotopic, and microphysical data set. To have this observation not only in winter and not only in one place, but distributed over many places. And of course, this implies tremendous technological, logistical, and scientific challenges that hopefully in a few years from now I'll be able to give you a bit more results on that. So to close, clouds and precipitation in Antarctica. They are important for the radiative budget and the surface mass balance of the ice sheet. It may seem kind of exotic, but we are potentially directly impacted by the sea level rise and so on. So what's happening there is important. Clouds and precipitation are poorly understood and characterized because of limited observations. And we know that the models have deficiencies. And to address these deficiencies, we need to be able to understand what's going on. Remote sensing brings added value. Having this vertical component is very, very helpful, and you gain a lot compared to only surface observation, as was the case until recently. So in terms of perspective, I strongly believe in a synergy between in situ as well as remotely sensed observation and model. You have to combine the two to understand what's going on, as hopefully I was able to convince you through these 2 case studies I showed before. And we need to go beyond observation limited to one season in one place to really have distributed multi-season data sets. And finally, the progress in technology and in logistics open new opportunities to do so, and that's exactly what WACA intends to do. This, I thank you for your attention.
I'm sorry for having pressed you. Especially the end makes such a fantastic link to our next speaker after. Is there someone who has a pressing question to Alexi? You will stay afterwards a bit? Can you?
Yeah, I'll be around.
But maybe someone who has a question now?
So the question is, how can we be sure that the sublimation is related to, the absence of precipitation at the ground is related to sublimation, not simply to advection to another place? Good question. The fact is, I presented here only vertical profiles, but we had a scanning radar for which we can do vertical cross-section of the atmosphere over 40 to 50 kilometers. And at this scale, assuming typical full speed and so on, if that was just purely advection, we should see snowfall reaching the ground somewhere. And we do not. We clearly have this sublimation over extended areas. So that's how we can be sure that the fact that we do not see any precipitation at the ground is really related to föhn, wind, and this sublimation effect.
Thank you very much. I'm very sorry I will have to...
No problem. Keep me out.
Yeah, I'm sorry. We will move on, but we will make a link to actually the logistics challenges that you mentioned, and hopefully we can also discuss your experience in that regard, as you are planning to use two of the main stations of IPEV. So I'm really delighted to introduce to you Jerome Chaplais. He came from Brest yesterday, so thank you for doing all that complicated intra-European logistics. His scientific work concentrates on paleoclimate, on glaciology, isotope geochemistry, amongst other. But many of you know him also as one of the leaders of the Ice Memory Program. And of course, he's here today as the current director of IPEV, the French Polar Institute Paul-Émile Victor. He will talk to us about opportunities for collaboration and also what we have in common, maybe. The floor is yours.
Thank you very much, Danielle. Good afternoon, everybody. It's a real pleasure to be here and from the other side of the western part of Switzerland to provide you some hints on what we do in France in terms of activities in polar regions. It will be quite different than what you have heard before. I'm not going to speak much about science. I will speak more about the means and about the policy as well, which is kind of a significant part of what we do in Antarctica. So, and I will start with these nice pictures of the remote environment of Concordia and with human beings doing science there. So I will start with the assets. What are the French assets when we speak about polar science? It was nice to see this introduction with Alfred de Gerlin, and I think each country has its own story with polar regions. And I must say the French one is quite rich. It started with Jules Dumont d'Urville. He was an admiral of the French Navy, and among his success, he was the first to put a feet in the so-called Adélie Land. Adélie was the name of the first name of his spouse, on 22nd of January 1840, so quite a long time ago. He discovered the coast of Antarctica on that side of Antarctica. Later on, we had to wait for nearly 60 years before France was back in Antarctica for significant activities, and it was related with Jean-Baptiste Charcot. He was a doctor by training, but he was fond of polar regions, and he really was fond about science. And with the two different ships, Le Français and the Pourquoi Pas, he conducted two winter rovers in the Antarctic Peninsula in 1905 and in 1909, and conducting science in meteorology, oceanography, biology. It was really a launching process for French science in Antarctica. And then again, many decades without anything. And it was thanks to the indirect push of Norway, which started to contest the French claim on Adélie Land, that Paul-Émile Victor convinced the French government just after the Second World War in 1947 to build up the so-called French Polar Expedition, EPF. And the objective of EPF was to relaunch French science both in Greenland and in Antarctica. And I must say it was quite a fantastic success, and we owe a lot to Paul-Émile Victor. And of course, other people which are named at the top, Jean Mallory, Claude Lorius when we speak about glaciology, and even people like Jean-Louis Etienne, who is an explorer, but who makes his best to help science, including now with his project of a polar pod, a drifting buoy with humans on board, which will drift along Antarctica over 18 months. I think the second asset we have in our community is that we cover actually all scientific disciplines you will find in polar regions. And more than that, there is a very strong interdisciplinary approach on science. And I think this is really the way to go, in addition, of course, to international collaboration, a very strong network of collaborations. I will take one example, a project called CICLELEF. I love this project because it's about putting sensors on top of the head of elephant seals. And the original idea is, of course, to understand the elephant seal behavior, where they go for fishing, where they go for reproduction, what is their strategy for life. But because they have sensors measuring physical parameters and chemical parameters, they provide during their dive information on the Austral Ocean that we would not have otherwise. And it's really the link between this physical oceanography and biology in a way, which is quite fascinating, I find. What type of science do we support? So you will find the main big families, so Earth and space science, life sciences, and social sciences. Earth and space science, we have quite a lot of activities related with geophysics, like seismology, magnetism, gravimetric measurements done in different stations. The atmosphere of polar regions is special. It's special in terms of physics. Alexi introduced that with the precipitation. It's quite special about chemistry. Everybody heard about the ozone hole, special chemistry over Antarctica, but there is a special chemistry even at ground level. So this is a big topic, and a lot of scientists we support work on atmospheric processes in polar regions. Oceanography, of course, the question of the behavior of the oceans, Arctic Ocean, Austral Ocean, the carbon cycle, carbon sink in the Austral Ocean, the behavior between floating ice shelves and ocean circulation and how it could affect the dynamics of glaciers. This is key topics on which we have quite a lot of people working. Glaciology, of course, when we are in polar regions, ice is everywhere, snow, frozen soil, and so on, so it's a big part of it. But astronomy as well. Astronomy is part of the activities in Antarctica, because when we are on the plateau, it's quite unique conditions to look at stars, or to look at planets for a very long time in a very dry environment. So it's good to do infrared astronomy, and we can look at the same body in space for many months in absolute darkness. Life sciences, it's related with biology and ecology. Of course, we have a lot of specific species which adapted to this environment, which leads to a specific biodiversity. But the big question as well is how these species can adapt to the evolution of this environment due to the pressure related with global change in general, and even pressure due to human activities, especially tourism, now becoming stronger and stronger in polar regions. Life science is also about biomedicine. Human beings living in polar regions are a topic of science. How people behave when they are pushed under extreme conditions, social conditions, physical conditions. This is something we handle especially with the European Space Agency. Since 2006, we have an agreement because they use Concordia Station as the best analog in anticipation of the future human expeditions toward Mars. So right now, I think we have something like 15 projects related with biomedicine handled at Concordia Station every winter over. Social sciences is mostly focusing on the Arctic because we have the local populations, autochthonous population, which adapted to this environment. And the big question is what they will do in this challenging context because the environmental conditions are changing, the economical conditions are changing. And last but not least, I mentioned engineering, and I put in parentheses START. I tried really to push over the last few years to get more and more engineers working on different technologies related with energy, related with telecommunication and so on, to get interested by polar regions, because it's an ideal place, I think, to push their concept and to help other disciplines getting the data they want through clever ways. I think a peculiarity of the French system about polar science is and more generally about science, is long-term observations. We started observations in geosciences and life science for a very long time. I illustrate that with this picture of this guy looking at a magnetic sensor in the cave at Concordia Station. Actually, the observation in Adélie Land in Antarctica started in 1950, so it's really an old and long series of observation. For life science, it's quite spectacular as well, because we have a continuous survey of 27 bird species, 4 marine mammal species on 4 different sites in Antarctica and subantarctic islands. And these observations started more than 50 years ago. This picture you see here is a rookery of emperor penguins next to Dumont-d'Urville. And actually, Dumont-d'Urville was built on an island called Petrel because we discovered this rookery in 1950. And France decided that it should be the right place to build up a station and look how these animals behave through time. A third asset, in my opinion, is the fact that we have a national operator, the French Polar Institute, acting in the polar field, and which is at the service of all scientific institutions. We are not on the same model as you will find with AVI in Germany or with BAS in the UK or NIPR in Japan, where there are scientists within the operator itself. The operator is serving all the institutions. And I think the good of this approach is that there is no, I would say, favorism in a way for scientists being on board the system. And that means that the scientists themselves, they are within research units where there is polar science, but not only polar science. So it's quite important as well to open the mind and to get grasp and ideas from different fields as well. So we serve, of course, CNRS, that's the main research body in France and in Europe, the Atomic Agency, CEA, the CNES, the Agency for Space, Météo France, the museum provides a lot of projects that we support, and all the universities, basically. And we do that through a unique call for proposals. So any scientist in France who would like to work in polar regions goes through the call for proposals that IPEV launch every year. You have this pie chart showing you for the next campaign, 21-22, Austral campaign, and the winter rover for Antarctica and subantarctic 22-22. We're going to support 90 projects altogether, and these 90 projects are transformed into 133 field campaigns, because many projects do not use one single district, but they are implemented in different places. The pie chart shows you where this project takes place. So the red part is Antarctica, the yellow part is the subantarctic islands, and the blue part is the Arctic. So as you can see, Antarctica is the biggest part, 39% of the project and the campaigns. Subantarctica, 36%, Arctic, 25%. Of course, our specificity, which is different than Switzerland, is that we decided to have our own infrastructures at the service of science. So where are they? In the north, we operate this station called AVIPEV, located at Ny-Ålesund in Svalbard. It's a deal we put together with Germany since 2003, and I must say it's really a success. It brings up a lot of science, very good science, out of Svalbard. And as a reminder, at Ny-Ålesund, we have 10 nations being involved to conduct science. So France with Germany do a pretty good job. As an operator, we deploy scientists in different places in the Arctic as well. So that's in the Russian Federation, in Canada, Alaska, Iceland, Norway. So it's not only about Svalbard. But Svalbard, we have a permanent infrastructure running all year round. Our main assets are clearly in the south. You have on this picture the so-called subantarctic islands. So this is Crozet Archipelago, Kerguelen Islands, and Amsterdam and St. Paul Islands. They are distributed from 37 degrees south, Amsterdam Island, down to 49 degrees south with Kerguelen, and that provides quite a nice coverage for both for life science and geosciences through the Indian Ocean. And then, of course, Antarctica, so Adélie with the Dumont d'Urville station on the coast, and Concordia station that we built between 1996 and 2005, and which runs continuously since 2005, together with Italy. A few pictures to show you these assets. The one on the top left is the so-called refuges. We have about 40 refuges distributed in Amsterdam, St. Paul, Kerguelen and Crozet, so that scientists can work on this huge space, not only focusing on the station, the main permanent station, but having the possibility to work and live in other places. So you see on the right, you have this map of Kerguelen Island. To give you an idea, Kerguelen Island is nearly as big as Corsica. It's quite big. And every dot you have is one of our refuges, which are available for scientists to work in different settings. Then Dumont d'Urville on the lower left, I put the flag of the French, Austral and Antarctic territories. It's this peculiarity of the policy, French policy, because we signed the Antarctic Treaty, but we consider that we are in our own country, in a daily land. So it's kind of a weird system. So we have an administration in charge of that. Concordia together with Italy, and Spitsbergen with the Avipep station together with Germany. And the picture you have on the lower right is the so-called French property in the Arctic. This is a station called Corbel. It was built by Jean Corbel in 1963, and the Norwegian government, because we are on Norwegian ground, considers that this is a French property. So very small, 100 square meters on Norwegian soil. Yeah. It's not only about having infrastructures to support the science, it's about the logistics as well. And the logistics in polar regions, this is maritime, terrestrial, and airborne. I show you here the assets we have for the Antarctic, and of course we have different assets for the subantarctic islands as well. First of all, you have on the map our general logistics. So we start from, where is the pointer? This one. We start from Hobart in Tasmania or from Christchurch in New Zealand. We use either aircraft, Airbuses or Hercules C-130 to usually reach Maiozukeli station. This is the Italian station on the coast, our main hub on the coast. And we use the L'astrolabe supply vessel you see here to carry a lot of people and cargo as well to Dumont d'Urville. And then we have this kind of fancy triangle going from Maiozukeli to Dumont d'Urville and Concordia, where we use these airplanes operated by Italy with twin otters and Basslers to carry most of the packs we transfer to Concordia station. And in between Dumont d'Urville and Concordia, we have this fancy traverse system, heavy-duty tractors with groomers and sledges, and to carry everything required for Concordia station. It's quite a unique system. It was developed to build Concordia station, and we are quite happy to see that it has inspired other nations. China has developed a system which is similar now. Even the Americans are using a similar system now to refuel and provide part of the cargo to South Pole, Amundsen Scott Station. So this is on what we rely on. And actually this type of convoy, we are able to organize dedicated scientific ones, and that's notably what Alexi is going to use with his colleagues to set up these autonomous stations along the track between Dumont d'Urville and Concordia Station. In 2019-2020, we ran one of these scientific traverses from Concordia towards South Pole in unknown territories. There are still unknown territories in Antarctica, notably to study what the so-called megadunes, which are specific surface features we could see from satellite data, but we didn't really understood how they could form and how they could evolve. Now I will switch to the challenges, because of course we have a few assets, but we have some difficulties as well to overcome. Probably the first one is that, in contrary with many nations involved in polar regions, France has at the moment no national roadmap for polar regions. Not to speak about science only, it's about defense, economy, environment, and so on, which is quite astonishing for a country being involved in polar activities for so many decades. When the former Prime Minister Michel Rocard was named by Nicolas Sarkozy as ambassador for the poles, he was asked to produce such a roadmap for the Arctic. So that's what you see on the left. We had this kind of reference paper published in 2016 about the Arctic, but nothing on the subantarctic, nothing in Antarctica. And we had a scientific perspective for the Arctic as well, the so-called Chantier Arctic. You have a picture on the right, published in 2015, and it led to support 2 research projects. So it was a real disappointment for the scientific community that worked for about 2 or 3 years to define this roadmap, and then in the end to get 2 projects being supported with 500,000 euros each or something like that. So just a disaster. But there is hope. There is hope, and notably because this year France had the chance to organize the Antarctic Treaty Consultative Meeting. As you probably know, the Antarctic Treaty is handled today by 54 nations which signed this treaty. And these nations meet once a year to discuss about the governance and the main decisions for Antarctica. So this year it was in Paris in June. And we use this momentum really to push our government to do something. So it was opened by the Prime Minister, it was closed by our President Macron. And at that time, the President asked that we prepare a national roadmap for polar regions, including science. So hopefully there will be something. Something we miss as well in terms of assets is about the maritime access to the Austral Ocean and to the Arctic Ocean as well. So we have to rely on collaborations when possible, but it's really a limiting factor. We use the Lastrolab to do some science, but its main focus is on supply. So we have a lot of difficulties to really apply science with this ship. So that brings us to quite of a new landscape, because you have on this picture a French icebreaker, but it's not for science per se. It's called the Commandant Charcot. It has been launched by the Ponant Company during this summer, and you see this picture taken on the North Pole. It reached North Pole on September 6th. It's a real icebreaker, PC2 class, so very excellent performances. And the company is quite clever because they said that this ship should be used for science as well. I had a chance to be on board for the dry run, not to North Pole, but a bit before. And I must say the equipment are really impressive in terms of dry laboratory, wet laboratory, moon pool, reservation on the hull, reservation for atmospheric measurements. So probably it's the way we will go for the future, to do a bit more science in maritime conditions by collaboration with Ponant Company. And I will finish by saying that polar science rarely figures within the top national priorities. The priorities now, when we speak about science, is about quantum mechanics to produce the future computers. It's about biotechnology to produce new drugs for treatment of COVID or other diseases. But it's not about polar science, and that's really a pity because, okay, it's kind of a science of a niche, but it matters, and it doesn't require so much cash actually really to make it happen. And notably, we would like to come up with a kind of calls for proposals involving the French National Research Agency, ANR, dedicated to polar science. I will finish because I think time runs out. One of the clear objectives for us is to enhance our bilateral and multilateral collaborations. At the moment, what we have is Germany with AVIPEM in Svalbard. We operate a laboratory together with Canada called TACUVIC, providing a lot of support on the meridional transect. Concordia Station with Italy and the European Space Agency. We exchange a lot of services with Australia as well. And in progress, where with Daniel we work together on putting a memorandum of understanding between the SPI and the French Polar Institute. Our boards of directors said okay, so we just need now to sign. And that will help to put some more momentum between French scientists and Swiss scientists. If I look over the last 5 years, we got 14 projects involving Swiss scientists together with French scientists. That led to 50 field campaigns, so it's quite a lot. And probably the flagship is Awaka now with Alexi. But more generally, I think we should move toward more transnational access. We spoke this morning about the aspect of the carbon footprint, the environmental impact of science in polar regions. If we want to reduce it, we have to favor transnational access. Instead of putting new stations in Antarctica, where artificialization is already quite high, we should better make that nations which want to come in Antarctica to work use our assets, which are not fully occupied at the moment. So that's the main message I would like to convey. And with this, I think I will finish. Thank you.
Thank you very much, Jerome, and thank you so much for opening also to this discussion that we want to have later about collaboration and how to enhance bi or multilateral collaboration. We really feel that this is something where we as operators or supporters, service organizations can really add value to the work of the community. Are there any questions to Jerome? We have one here.
Yeah, so the question is about the aircraft we use equipped with skis. Actually, they are not the property of Italy. Italy operates them, but they are built by a Canadian company called Ken Borek, making twin otters. So there are two propellers aircraft with about 1 ton of payload. And the Basler is a DC-3 from the Second World War, which has been transformed into an aircraft able to work in polar regions. So the Basler is really a fantastic tool. And then these Basler, owned by Ken Borek, are operated by other agencies like Antarctic Logistics and Expeditions, or ALCI. Okay, so the question is about the Commandant Charcot reaching the North Pole from where it started. Actually, we started from Alesund in Norway, and because the main constructor was there in Norway, and then we navigated until Longyearbyen. So I had to leave the cruise there, and then it went from Longyearbyen to the North Pole, and quite fast actually. I think it reached North Pole in 6 days or something like that. And but there was no passenger. Well, there were a few passengers just to try because the vessel was not yet fully equipped. So we are there to check what was okay, what was wrong. So there was no official customers on board. The first travel will take place. First voyage will take place next November. So the Commandant Charcot goes to Antarctica, and the ship will go through original cruises. One of them is to start from Ushuaia, go all along the Antarctic coast, Antarctic Peninsula, along West Antarctica, into the Ross Sea, along the Ross Sea, and back to New Zealand. So 28 days, and it's a unique opportunity to conduct science on this kind of leg where basically nobody goes.
Thank you. Now we have two left here. One there.
Are there microphones apart from this one here? Well, I would say that one country in the eastern part of the world makes our life more and more difficult. You will probably imagine. But at the last Antarctic Treaty Consultative meeting in Paris, we really had a hard time. As you know, the Antarctic Treaty is run by consensus. So the 54 nations which signed the treaty have to agree. And for the very first time, we had a hard time to agree on anything. And because of this giant country making our life difficult.
Alexi.
Yeah, it's a good question. What we should do with private operators, and do we consider that because they transport tourists, we should not go with them? Or should we just use the opportunity? I'm more on the second option. In any case, they will conduct these cruises. And they do it in I would say, the best possible way you can think about in terms of environmental impact. This ship is the only one by a tour operator working in polar regions, running on liquefied natural gas and electric power. When we started from Norway, we started on batteries. It's amazing. It's really amazing. So that means you can approach the fauna, no noise, and no air pollution. It makes a difference. The waste treatment, water treatment, they treat gray water, they treat black water. They really push to the limit on what they could do on this kind of ship. So based on that, based on the fact that they will cruise in any case, I think we should get some good science out of it. It's well equipped, and now the whole point is to put a process for selecting projects, call for proposals for selecting projects, that the projects are not too ambitious because they're not going to stop the cruise for 12 hours in the middle of the ocean to put a buoy. No way, I think. But you know, there is a lot of science that could be complementary to this kind of cruise operation. And of course, we'll start with France, which makes sense. But my idea is really to open it broadly to the international collaboration. During the dry run, actually, we had 3 scientists from Norway on board. And we put 2 buoys in water. And they made some measurement, sea ice measurement. You have an instrument to measure sea ice thickness continuously, just in front of the ship, with real-time data, because it's useful of course, for navigating, but it's real scientific data. You know. It's very comfortable, I must say, even too luxurious. But
I'm not sure if all the costs are eligible from SPI, but
well, you need to experience the Astrolabe in any case to know what is the Antarctic adventure.
okay. I'm sorry to have to cut the discussion now, but thank you very much, Jerome. This was really interesting, and I'm sure, and you'll be here later also for people who want to ask questions about assets, about opportunities, and about the call that you mentioned. So thank you so much. We have a little something for you. Oh, the other way.
Oh.
And
thank you very much. This is
good. Do you want to come? Okay. So don't get frightened. We're not going to speak about SPI for 45 minutes. There is more to that section of the program than just us. But still, we would like to use this opportunity to tell you a little bit about what has happened in 2021 and what are our priorities at the moment, and a few ongoing things so that you are aware. This year, and this was mentioned this morning, one of our big priorities was to establish the SPI as an independent foundation. And if you haven't noticed anything, it's good. The aim was that it should be seamless and that even the grantees should not actually notice it. The aim was really to continue what we do, but from a different legal entity, which has now an independent status. As much as possible, help you and ourselves carry out a normal course in our events, in our support, in our grants, also being flexible, accommodating those of you who had to postpone field work, and so on. We have put, and you will see that throughout this day and in the coming session, a big emphasis on trying to enhance and launch new partnerships at the service of the community to help and support international collaboration. We carried out, in collaboration with ARI, Arctic and Antarctic Research Institute in St. Petersburg, and Geomar in Kiel, Germany, an expedition that Gabriela will tell you more about in a moment. And we are working on selecting the two big polar programs, SPI flagship initiatives, that we will select at the end of the year. So we are now waiting for the full proposals that are due towards late October. So this is about SPI and what is happening on our home turf. What is currently open in terms of call for projects is our two big calls of the year that are always published simultaneously, the exploratory grants, which are opportunities to kickstart new collaborations, undertake field work, international collaborations also, and the SPI Techno grants, which I mentioned earlier. I don't want to renew my pitch, but which has an increased maximal amount of funding this year, and we hope that this could also help enable partnerships with the private sector or startups with a maybe more attractive package. The next calls coming out are for our partnership with Po Helvetia, funding tandems of artists and scientists, Bollards. There will be an event at the end of November for those of you who are interested in the topic and potentially in the call, but who are also just interested in this issue of collaboration between arts and science. And the Polar Access Fund for Early Career Scientists fieldwork will be, as usual, at the end of the year, closing in January. For your diaries, the Polar's event I just mentioned, our next health and safety course, 3rd and 4th of December. There are a few places left, so if you're interested, write quickly to the Secretariat. The announcement at the end of the year of the selected flagships. And I just want to make a little bracket here for those of you who don't know the symposium dedicated to Connie Stephan that was due to take place in Davos next month, or this month, I have to get used to October, has been postponed to the beginning of next summer. And with that,
thank you very much, Danielle. So, Arctic Sentry. Yes, we were lucky to get out into the Arctic this year with a big expedition. And you probably ask yourself, what is Arctic Sentry? Why Arctic Sentry? So this cruise, this expedition should have happened 2 years, not this year, but last summer, to celebrate the birthday, the 100th birthday of the Arctic and the Antarctic Research Institute of Russia. Now, unfortunately, due to reasons you all know, it had to be postponed, and this year we felt we can't take the risk, go ahead with planning, and if everything allows it, just really do the cruise. And actually, this is the situation we faced. We were really lucky we could get out, and we could get out safely. Who were the people? How was this all organized? So it was co-organized by SPI, by ARI, and Geomar. And from Geomar, we also had the chief scientist, Heidemarie Cassens. She was the chief scientist. Then we had from SPI a co-chief scientist, Sam Jacquard. And then finally, from ARI, a co-chief scientist, Michael Makotin. And these three people have guided us through the Arctic, together, of course, with the captain, who is probably the most important person on the ship at that point. We were in total 59 scientists from 15 institutions. And you can imagine 59 scientists, they will not work on one single topic. So it was a truly multidisciplinary expedition, and that was really, really interesting for all of us. So what about sampling? What happened on this ship? Well, we had about 116 marine stations, 9 terrestrial landings, different islands, and we could do a quiz now on all the funny numbers. So, for example, how many liters of water were sampled with the Rosette? 20,000 liters, 20 tons. Not sure if that tells you anything, but it's a nice number. How many hours of atmospheric instruments operation do we have? 7,000. And it goes on. Length of sediment and ice cores? Well, 34 meters of sediments from the seafloor and 27 meters of ice cores. And those who are from these communities, they probably now understand how much work it will be, how much samples we took, how long people will work in the lab to really get the data out of all these samples. Well, what will we be doing with the samples? It's not so easy. Most of them are still back in Russia. And also for the data, we don't really have export permission yet. So this will be the first task of the SPI Secretariat, together with Geomar, with ARI, to make sure that we can really get the samples to the labs outside of Russia for those samples where other teams are working on, apart from the Russian teams, of course. This might take weeks, 2 years, depending on the samples. And we hope we can restrict it to within 1 year. And then second, of course, then when we have the samples, we want to analyze it and really address the research questions we set out before going out there. So, for example, what is the mixing of the Atlantic waters with Arctic water masses? Then, how productive is the sea, and what are the biogeochemical fluxes between the atmosphere and the ocean? How do land areas contribute to cloud formation through aerosol formation? But then also, what organisms are living at the seafloor? Then questions, of course, related to long-term climate variability and to climate change, such as testing if climate change can be tracked by trace elements, and what ecological impacts we see from climate change, but also how did sea level change with climate on the terrestrial land through sediments. And finally, a lot of ecological questions came up. So micro and macroplastic was sampled in the sea, but also on land along the beaches, to understand how the water is transporting macroplastic, where the plastic is coming from. And I can tell you, it's not all from Russia. It's also coming from other parts of the world. And then Peter Ryan, he stood on the bow for many, many hours, many days, I would say, counting birds, counting polar bears. He wanted to understand how the bird species are distributed across this area in the Kara and Laptev Sea. And finally, we did some sampling on land to set the baseline for future biodiversity studies for plants, but also for soil microbes. Well, at this point, we don't have concrete results yet, obviously. We are just back. But still, I think already some of us have changed their hypotheses after seeing the area. If Jerome talks about ESA, I think they should consider some of the northern islands for their training, because on some islands it really felt like landing on Mars, apart from water being available. But otherwise it was exactly that feeling. And I think the best thing to give you some impressions and to compensate those who have not been so lucky to be out there, we will show you a video. It will take 7 minutes, but I think you'll be impressed by what has been going on. It's still raw, fresh material, but I thought it's nicer to have this than waiting another half a year or a year until we have the polished version. So please forgive us if the tone is not perfect, if there are some quick things that change, but we would like to ask now for the video to get on. Enjoy.
So they will have 13 stations across this transect. It's going to take about 24 hours. Поехали. 20.
Да не мовтуйте! Да. Sea Devils.
We finished the atmospheric profile.
More solid, more compacted. Up. The structure will destroy and then it will. this extended depression.
Gut, ja.
So I hope that gave you an impression, and if you have more questions about the measurements, you probably have recognized a few of these suspects in the video sitting here in the room. I think it's about, not half the room, but about 20 people who joined, and I'm sure they are happy to answer any questions during the apéro for you as well. We now go one step further in the international collaboration. So Jerome already presented some ideas about the French research, and maybe already some of you have some ideas how to profit and collaborate with IPEF in the future. And this will of course be supported by the new Memorandum of Understanding we are going to sign. But we also invited two other people exactly for the same reason. So you are exposed to what they are providing or what they could provide as assets, and that would really facilitate access for you to Arctic regions. And as we discussed already several times, that we also should have more access for the humanities, I think it's especially welcome that we have today with us Martin Rayard, who is here from Parks Canada. He is actually the, let me check about that, the chief scientist of the Parks Canada, and he lived with Arctic communities for 14 years. And I think this is exactly the point that makes it especially valuable, that you're here and that you also give different perspectives. You know, we are not only researching about snow and ice, about ecology, but we are of course increasingly interested also in working together with local people, with indigenous people living in the Arctic. So please, Martin, I would like to ask you to present a little bit about potential opportunities for Swiss researchers in the Canadian Arctic.
Good afternoon, and thank you for the opportunity to be here. It's exciting to see this Swiss Polar Institute launching into a new chapter here, and looking for potential ways of expanding their international collaborations. And I'll be talking today of what's there, opportunities are there in Canada. I really would like to point out maybe right first that we do not keep your samples for years. So it's just and there's other reasons why it's potentially good. So I'm here to provide a bridge for people who might be at some point interested in working in the Canadian Arctic. And I'll be in Switzerland for an entire month, thanks to the Swiss Polar Institute, and available for networking if any one of you has an interest, says, oh, this might be interested or that might be interesting and likes to follow up. I'll be here for the apéro. And also the next month I'll be in Lausanne for this coming week, then in Bern for a week, then in Davos for a week, and then in the Zurich area for a week. So I'm available to meet and discuss further what kind of projects Switzerland might want to undertake in Canada, what organizations are there. I lived 14 years in the Arctic, as Gabrielle said, but I've worked in Arctic research for 35 years, based in Canada, so I know pretty much everyone there. It's like a small family, so I can be that bridge if you're thinking of expanding research into Canada. It's not an easy place to get into sometimes because of permits, and some of you have tried. You have to know who is who, and I can help with that. So that's what I'm here for. So the next couple slides, I show you some of the research that's happening and some of the opportunities in Canada, but do feel free to follow up. My address is at the end there. I'll be happy to make time for people. If you can't meet with me today, could be on a later date as well over the course of the next month. I'm here to assist. Good, so with that, why Canada? Canada, of course, has the advantage of covering 25% of the entire global Arctic. And that's not just any part of the Arctic, it's actually a vast gradient. North to south, it has mountain ranges, and it's relatively well established infrastructure. It has a network of many research sites. Every blue dot on this map is a research station, which could be as small as a little cabin and as large as the Canadian Arctic Research Station, which was just completed and is a $250 million research facility. You will see some more slides on that. We have excellent logistical support through the Polar Continental Shelf Project that just got a funding boost, has $15 million just for logistics, flying people with airplanes or helicopters to the most remote locations, providing camping gear and so forth. So it's well established. We have a good permitting system that is not straightforward, but it's well established, so we know how to go about getting the right permits. It's relatively easy to work in Canada, the visas are easy to get, and we have good infrastructure. In addition to these research stations, the blue dots you just saw, we now have a new opportunity, and that's the collaboration through a network. We have in the middle here that just popped up, that's the Canadian Hierarchic Research Station on Victoria Island in Cambridge Bay, right in the middle. And then these green fields around, that's the national park system. There are 11 national parks in the Arctic in Canada, some of them as big, each one, as the size of Switzerland. So that's a fascinating network that just got established last year that provides this integrated, logistically integrated network of sites. If you like do monitoring in the similar way in several locations, you can do that now, because each of the national parks is logistically accessed every year through staff. They have their own staff, and most importantly, they have connections with the local communities, with Inuit, and they bring their traditional knowledge. They can help with logistics, how to operate, what the important research questions are. So that integration with northern people is very strong and very important in Canada. We cannot do research anymore there without having that base, and this network helps with that. It's very difficult from Switzerland to establish those close links with communities. We have people who do nothing but that in the park system. That's their job. So linking Swiss researchers with that network really helps facilitate that research. That's one of the Arctic national parks, happens to be my favorite, Ellesmere Island. That's where I did my PhD research on muskox. So it's just an incredibly beautiful place if you imagine that landscape without a single sound, that's complete silence, and a vista you can see 100 miles uninterrupted. It's just an incredible place. You can do glacier research, freshwater research, terrestrial research in that location. Another one that's really attractive, Sirmulik National Park, northern Baffin Island. Again, glacier research possible. Any type of high altitude research that you do in Switzerland could be duplicated there in high latitude research. And then, interestingly, we also have this new marine protected area north of Baffin Island, Lancaster Sound. Talurutiup Imanga in Inuktitut is the world's largest northern marine park. It's absolutely vast, and it was designed to help Inuit provide an ecotourism base, and has been developed with their input and their guidance, I would say with their leadership, and it's done through complete cooperation. But that opens up the opportunity for marine research. Some of you are familiar with that area, know that there's, in the center of it is the so-called Northwater Polinia, an area that is ice-free year-round, and therefore attracts abundance of marine mammals, narwhal, for example. So it's a real biodiversity hotspot and a fantastic research area for marine researchers. I just talked today to an artist who actually liked to study narwhals up there and might have an opportunity to go there. So that's from Switzerland, so that's very exciting. Further, the CHARS campus, the Canadian Hierarchic Research Station, that's that $250 million state-of-the-art facility that I just mentioned. It is in Cambridge Bay, right beside the community, and the front third of it is accessible to the community. So we talk to Inuit every day. They come to the research station. They're employed at the research station. So it's really at the service of northern people. But it's also available to Swiss researchers at the cost of zero. So you can go and do research there, including accommodations at absolutely no cost. You'd have to get yourself there, but once you're there, it costs nothing to use the facility, the labs, the accommodation. So there's two buildings with 48 bunks that you can access. So that just opened a couple years ago and is now fully operational. We do have challenges, however. It doesn't sound as perfect as I might have initially presented. So to be honest, there are some challenges to get the right contacts in Canada, and that's why I'm here. Because there are a lot of people you need to know in the north who does what kind of research, but also you need to know community representatives. It's not enough to just know the researchers, you need to know who lives there and how do you make your project set up in such a way that it benefits them, that they're participating, that you have research assistants that come with you that are from the communities. That's usually a win-win situation. Your project gets better, they benefit, you have long-term impacts. So how do you set that up? How do you get the contacts? That is a challenge. There's some challenge in navigating Canada's permitting system. That's not necessarily straightforward because we have 3 different territories. We have Inuit-based permits from the hunter and trappers organizations. We have federal permits, so it's slightly complicated, similar as in Switzerland, where we have cantons and towns that all have their own regulations. We got the same in Canada. But again, to navigate that, there is an organization now in Canada that is called Polar Knowledge Canada that helps with that. And I can point you that direction. And there's a requirement for Indigenous participation. To address these challenges, I'm posted here, as I mentioned, for a month. I can provide the contacts, and I will be developing a report for the Swiss Polar Institute that's going to be a tool that shows you what are the contacts, how do you do research in Canada. That's the title, and I'll try to tailor it as useful as possible to the research community in Canada. So I have a month to get that going and provide that to the Swiss Polar Institute. And as I mentioned, I'm available to meet. We recently had a successful collaboration with the United Kingdom. where we jointly funded $28 million of research. Canada put in $14 million. The UK put in $40 million. We involved indigenous community right off the get-go, and we chose the research topics with national Inuit organization and the communities, the UK and ourselves. Not surprisingly, climate change features strongly in it. And also we have infrastructure questions that northern communities have. How will permafrost melt, for example, affect their buildings and such? So that's a project that just started through a call for proposals for the $28 million. The call has just closed, and we are assessing the proposals that have come in. Research will start next summer for 3 years. So it's overall a 4-year time frame. My contact information is here. If you like to connect with me over the next month, feel free to jot that down or meet with me during the aperitif. Thank you.
Thank you very much. In the interest of time, we're going ahead, but I'm sure you're around. You offered this to everybody. You'll be around in Switzerland as well, so an ample possibility to discuss, hopefully. Now, we also had this idea to discuss with the Chilean partners. The idea was to have the director of the Chilean Antarctic Institute here by Zoom. Up to now, I understand this has not been really successful. They are running late. Okay. So maybe just to inform you, we met earlier this year, Danielle, the Chilean side, and myself. And actually, I was really impressed by how much research the Chileans do in Antarctica. And the program seems quite open. And a list of the projects that are available and where they also look for collaboration is actually in front here, Danielle said. So please feel free to look at this list, to study it, and also see some potential for collaboration. While we are waiting, I think we could pick up the other discussion. Did you want to lead that? I just go, okay. I go further one slide. So the idea is really to enhance this collaboration. So we take additional measurements, and we of course really want to provide access to research infrastructure at the 3 poles. And how can we do that? Through information and networking services for all career stages. That's really important to us. And then really also have international exchange on technology and methods. We heard it several times today. Technology is still one of the limiting factors, and I think we should exchange more within Switzerland with our technological institutions that are really strong in that component, but also then with other people who actually, with other scientists, with the communities who are out in the Arctic, in the Antarctic, and in the high altitudes and latitudes, of course, to really exchange more about technology. And then, of course, really support you with fieldwork services. So we wanted to reach out to you. We had a lot of internal discussions already, how to support you better in doing polar research, but we also wanted to reach out to you. What exactly do you need? What we are currently doing to really enhance that collaboration is building up these collaborations through institutions. Of course, this is kind of a top-down approach. We only sign a memorandum of understandings if we really understand that there is some interest from the scientific community. But then still, we also want to allow and have to allow initiatives that come from bottom up. So do you have any ideas, any wishes where SPI can invest to enhance access to polar regions for you? Maybe we'll let's think the question for a minute. Yes, there actually no time required. So you're addressing the question whether we want to establish specific collaborations with really specific institutions, or if we can help to facilitate that. I think Danielle was smiling, and maybe she has an answer for you.
So more specifically, the question was also about learning indigenous languages and opportunities to that regard. I think it's exactly what this session is about, is collecting this type of ideas, which so far had not reached us. It's not foreseen in the current agreement that we have with IPEV, because, well, that's not what IPEV offers, and but it doesn't mean that there are no other French actors we can work with if there is a demand and if we add a value. I think this is really what we should look at, is, are these courses, for example, not accessible for Swiss participants if there is no agreement? The added value that we seek to achieve, for example, with the agreement with IPEV, is that Swiss researchers, if they don't yet have a partnership with French researchers, would still be available, and I speak under your control, eligible to access logistic means or stations, which is currently not possible. So we seek this added value and what is not possible yet. So you're very welcome if you see that there are impediments and that, for example, these courses are not eligible for non-French based researchers, for example, to contact us, and we can see whether, if there is a demand, we can discuss with them.
Very good. I mean, this is a more dedicated course, of course, and then we have the possibility for summer schools and so on to also apply even for funding to go there. But I think your question was a bit more specialized for really longer term expertise. We do have another question in the back. Almost not, to be honest. Thank you very much for this information already. So it's actually good that we connect. So maybe that is already helpful. Yes, and then you had the second point.
If I understand your question well, you wonder whether we could support making Swiss academic institutions more aware and more involved in New Arctic, as some already are. Is that what you're saying? Yeah. Okay. Do you want me to say?
I mean, this is, of course, a question that is up to the single institutions, whether they want to be partners and members of Arctic or not, and if they want to pay that fee. But of course, the SPI could distribute this information and of course support and say that the Swiss polar research community is interested. You had a follow-up. This is correct, but I would expect, and we would need to check that with Arctic, we are not, in this sense, an academic institution. So we are not directly a research institution, but we are a national infrastructure to support research, which is a slight difference. But we can discuss this point later on again, if you like. Thank you. Any more ideas, wishes? Yes, Andreas.
I was wondering whether there could be some support for companies that get these variants and sometimes agree with it, and we need to know what it's not what. And the other thing is something mentioned from the Sentry exhibition, shipping of equipment and samples and having a contract
Yes, thank you very much for this point. I very much understand what you mean. I think it's very country-specific, and sometimes it even changes from year to year, what exactly is needed and what is allowed and what not. I think we really need to discuss this, how we could help you with this. I think as it is country-specific, we would need to have very strong partners in every country to help us with that. But I understand that for scientists it's very cumbersome, tedious to every year get these permissions again. I fully understand your point. So I hope it's noted down. Thank you. Yes?
I was surprised when you mentioned international collaboration that you don't mention Russia, because of course that's one of the most important ways we can help polar research.
You mean in the 3 examples we brought to the table today? Yes.
Canada is 25% of the Arctic, but Russia is 50% of the Arctic. And I think SBI has more openings into the Russian polar world than many other similar institutions.
I fully agree. And I think we are already successfully collaborating with Russia. That's one of the reasons maybe. And we also want to open up new and other opportunities in other countries. But I fully agree that Russia is a strong partner, and I think with Switzerland we have a very different perspective and position to collaborate with Russia compared to other countries who might be more bound to some political restrictions as well, but definitely also at the international level we very strongly support the collaboration with Russia, definitely. And it's yes. I agree, and what is happening now, for example, in the collaboration with Russia, it's very often the scientific institutions who help us with that, even for free, actually. And also for them, it's a real burden, so very often instead of really collaborating with us scientifically, half of the year they are busy with running all these permission processes, which is a real shame. So if we could really move these processes to a different entity and then really concentrate on the research, that would be really, really a way to go, I think. Any other question? Yes. So actually, technology is one of the 4 pillars in the science plan that is lying here on the table. It's, as the humanities, one of the topics that is still a little bit in its childhood, I would say, in Switzerland. I think we have to increase collaboration with our excellent technological institutions here in Switzerland to foster exactly this part from the SPI side. If you have any such connections, if you know of technologically oriented people who are interested to work at the poles, to test their instruments or to help develop further this instrumentation, let us know. You know, I think we really also rely on the contacts you as scientists have. If you know that somebody is really your technology partner, and then also we do have these techno grants that where you can submit some of the ideas and even get some additional funding to further develop. So if you have good tech partners, yes, use them. Let us know as well about them. Yes. Yes.
So the universities of applied science are totally eligible for funding schemes of the SPI. And, well, the two calls that we mentioned before that are open. One of them addresses exactly the issue of technology development for work in the field and in polar regions or high altitude regions. And there is actually quite a nice budget available this year for this instrument. So maybe you have 3 weeks to think about it.
Okay, our Chilean partner didn't make it, unfortunately, but we keep on going with the discussions with them because I'm very sure it's offering also really nice collaboration opportunities. And if you're interested, also anytime feel free to come towards us and just ask about this program and how we can facilitate collaboration. With this, I would like to hand over to Sharmili. She has another agenda point now.
Yes, so as you know, SPI supports research and field works of scientists, Swiss polar scientists. So we are pretty aware of what is going on in the field, but we want for other members of the community to also be aware of it. So that's why we try today to make a little selection of presentations from Swiss polar scientists. They are going to present their research, their field work. There are a lot of speakers actually, so we are going to be very strict on the timing. Please understand this, and thank you very much. So our first speakers will be Horst Margut. Please.
Okay, so, oops, that's the wrong way. Yeah. In the year 2012, for a period of a couple of days, the entire ice sheet, the entire Greenland ice sheet surface underwent melting. This was an extraordinary event, never before observed during the era of satellite observation. Typically, as you can see here, white is no melt, red is melt. Typically, most of the ice sheet undergoes no melting at all during a summer. This extraordinary event was broadly reported in the press. This here is, oops, how does it work? Yeah, this is my favorite headline. So, but we all know it doesn't go that fast. Nevertheless, Greenland is probably the largest cryospheric contributor to sea level rise, and the current mass loss of the Greenland ice sheet is dominated by surface melt. However, from all the melt that is generated on the ice sheet, it's only about 55 to 60% that actually runs off and contributes to mass loss. And the big question here is, of course, now 2012 was an extreme event, but such events could become more frequent, and will this percentage here remain stable in the future, or might this increase? Or expressed otherwise, if we want to project Greenland's changes and sea level rise contribution in the future, we have to understand the hydrology of the meltwater on the ice sheet, and especially in those areas newly affected by melt. And this question here, which I formulated here, is also what we are working on. We are a group of 4 researchers at the University of Fribourg. This is Nicolas Julien, Nicole Clerks, Andrew Tedstone, and myself. Our funders, the project is mainly funded by the European Research Council, but since we started in 2019, we have also found some more funding, some smaller sister projects by the National Science Foundation and by SPI. I was asked to tell you briefly what we have been about since we were struck by the pandemic, so half a year after the project started. And, oops, this is a bit tricky here. oops, because the order is, yes, is the wrong way somehow, complete chaos. Okay, so yes, the project and these two other projects, we have basically 3 pillars here. We want to track the surface runoff on the Greenland ice sheet over the satellite era, or as much as possible of the satellite era. We want to measure firn hydrology in situ on the ice sheet, and we want to then use these data to understand better how Greenland will change into the future. Let me see. Yes. So what we're talking about, what is surface runoff on the Greenland ice sheet? It looks like this here. This is just one example here from the year 2012. These are streams here on the ice sheet. They can easily be several hundred meters in width, these braided river systems. And we have already mapped them all over Greenland. The result is here. I can see that it's not so easily to recognize. In bluish colors here is the extent of surface runoff around the year 1985. Here, the reddish colors is the change that has happened since then until now. So we're using a variety of remote sensing products with these 3 goals, which we have now, by the current time of the project, mostly achieved. We have mapped the long-term changes in the visible runoff extent on the Greenland ice sheet. We are working still a bit on the tricky question, which is how does the subsurface, the near subsurface, change? And we have also basically finished with having also annual, sometimes daily resolution records of where does runoff happen. So we also want to know that stuff that we see on these satellite images, how does it look in reality? And we are working at the runoff limit, so that is the highest elevation on the ice sheet where meltwater actually surfaces and runs off. And if you work in this area, it's a bit peculiar, as you might see here. So digging snow pits in this area is a bit different from usual conditions. Since the project started, we were able to do 3 larger field campaigns in summer 2020, in spring 2021, and in summer of 2021. The goals are to measure firn hydrology, to measure the surface, the hydrology of the water. We also had some measurements which we had to carry out in a lab-size environment, lab-type environment, but the samples are just difficult to transport. So we called that a pop-up laboratory, which we ran on the ice sheet. And we have installed a network of 10 GPS or firn measuring stations that measure autonomously. Finally, we want to draw from these data that we have acquired in these 2 first pillars and understand better about modeling of these processes into the future. This has just recently started, but I can share here one first result is we thought that now that we have here the map, which you can see here a little bit, the runoff extent, the surface runoff extent from the past and now, how do the climate models, the tools that we use today, actually simulate runoff in these areas? And the result is shown here as a cumulative amount of surface runoff of the 2 most important regional climate models. And what we found is that they differ by a factor of 2. So this is now for the relatively modest areas that we have in currently. This also tells us uncertainties are large, and we hope that we will be able to contribute something to reducing them in the framework of the Cassandra project. Thanks a lot.
Our next speakers are Andreas Vieli and Martin Luthi from the University of Zurich. The floor is yours, and I invite already Francesca Pellicciotti to get ready after it.
Thank you. Andreas Vieli and I will present 2 projects that we do in Greenland. I don't know which one comes first. It's yours. So.
Actually, this project is led by Isabel Gärtner-Röhr, which couldn't be here. It's about the dynamics of rock glaciers. So this is frozen sediment that creeps down the slopes. There's quite a bit of research in the Alps about this, and also sort of more geomorphological research on rock glaciers in the Arctic, but there's very little known about how they flow, how fast, how they interact with the climate, and so on. And so we wanted to know How do they respond to precipitation, meltwater, changing temperatures? And we installed this summer, or my colleagues installed this summer, a few permanent GPS that will be staying there for the next 2 years, measuring positions all the time and velocities. They flew some drones to get velocity fields, repeated drone flights, and we installed simple meteo stations and ground temperature sensors. The results probably will be exciting next year, so we have to wait a little bit, but all this stuff is out there and running, and we hope we get some exciting data soon.
Okay, this is on Disco Bay, in Disco Island and Disco Bay. This is the slowest moving part of the Greenland cryosphere. I investigate the fastest moving part. This is Jakobshavn Isbre, moving at around 2 meters per hour, continuously. And we have a bigger project funded by the Swiss National Science Foundation to investigate the dynamics of this ice stream. A lot has been done about the calving happening out here. At the calving front, huge icebergs break off there. This project is more about figuring out why this ice stream flows so fast. Nobody knows, really. And there's certainly lots of fracture processes involved, lots of short timescale processes that are not continuous. And all glacier models at the moment assume Glen's flow law, continuous viscous flow. That's certainly not the case. As you can see here, the whole landscape is completely cracked. We installed lots of stations, or we will install more, and we have installed like a few stations this year in an exploratory campaign on the ice. Back here, measuring seismicity, speed. We have meteo stations. We let interferometric radar run to get velocity field every minute. And we will do frequent drone flights indicated by these nice red loops here. So next year we will have a big campaign trying to figure out what's happening in this ice stream. This is a collaboration by a few institutes. We collaborate with seismology, Fabian Walter from WSL. Then we have a lot of drone flying expertise from Guillaume Jouvet. Joan Goma DPFL has this incredible model, particle model, to really figure out short time scale processes. And then we have PhD students and also postdocs working on this project. Next year will be the big thing.
Now it's Francesca Pelliccioti's turn from VSL, and I invite Loïc Pellissier to get ready.
Explain me so that I avoid
Just like this?
Just on the front, yeah. Thank you very much. I lead at VSL a group that is called HIMAL, High Mountain Glaciers and Hydrology. And indeed, what we study is glacier changes, glacier processes, and the hydrology and water resources of high catchment in a changing climate. This is where we work. We don't work in the poles, so we don't work in the Arctic, and we don't work in the Antarctic. We work, this is a pointer, in 2 major regions, which are the Andes of Chile, since 2005, in fact, Peru. I just got a new project, and also a new project in Bolivia. Oh, yeah, I knew that. Okay, let's start again. And in this, since 2011 in this region, this is High Mountain Asia, one of the most important water towers in the world. We have projects in Nepal, Tibet, Pakistan, and India. You can imagine that COVID didn't help us in that situation. When I got my ERC in 2018, that was a ERC Consolidator grant, this is what we planned to visit over the next 3 years, and that was 2018. So what we managed to do was fieldwork in Langtang and Tibet. Langtang is in Nepal and Tibet, and Palung Glacier and the surrounding catchment is in Tibet. I'm just going to show you a quick example of what we did. We took traditional measurements of glacier mass balance, meteorology, hydrology of the catchment, but we also focus on those features, which are cliffs and supraglacial ponds, the forms of the debris-covered glaciers that are very common in the region. And then we use all those measurements to understand how those cliffs and ponds develop and what is their contribution to the total mass balance of the glaciers. We really try to use, we are a group of modelers, but we try to use extensive field data to go from the scale of single processes and features to the glacier scale and understand their importance for a single glacier, up to the catchment scale to understand their importance for the hydrology. But we also use extensively physically based model to work at the regional scale. These are the results. I'm just trying to I hope this is a good resolution. This is the altitudinally resolved mass balance, so not a single value per glacier, but really altitudinally resolved for every single glacier. I knew that, yes. For every single glacier in high mountain Asia. These were all work we did with the data of 2019. And then COVID came. And all our plans for fieldwork in 2020 are exactly that. There was no fieldwork. We did some fieldwork in the Alps with Andreas just to do something, so to say. Came 2021, and we ran the risk of ending up exactly in the same manner. But then I have to say, in the tragedy that COVID brought, there were also some very good aspects for us. It forced us to rethink our study sites, to rethink our questions too, and this is what we ended up deciding. So this is the same image I was showing you earlier, and if you see, this is the per glacier, the mass balance, mass losses in red, and everything is red fundamentally, or mass gain, the scale in blue. And 0 is more or less yellow. And you see this very well-known phenomenon by now of the Permia-Karakorum anomaly. These are glaciers that are in a neutral state or in a positive state gaining mass. And so we decided to focus there. And that was quite an incredible thing, thanks to collaboration with a number of people who are sitting here. Martin Oelsle was very generous of his time and connections. And so we managed to focus on this region, which contains the only growing glaciers in the world, the so-called Karakorum Permia anomaly, but also the most vulnerable basin in the world. This is the Aral Sea, the Amudarya, Sirdarya, the most vulnerable basins in the world in terms of water resources. These are the findings of a paper by Walter Wintershell and co-authors in Nature last year. So we managed to go this year in June 2021 was a beautiful experience. And in September, again, I didn't go in September, but Ashilu who was sitting next to me, still sitting there, just came back yesterday from Tajikistan. We took measurements of hydrology, meteorology, glacier mass balance, surface processes on one specific glacier and its catchment. And our intention really is to equip that as one of a second LANCTA, so to say, a long-term monitoring catchment where a number of research institutions can work. So we took measurements of high elevation precipitation. We set up automatic cameras for tracking those cliffs that I showed you early on the Nepali glacier. This is Maren, one of my PhD students. Measurements of the hydrology, boundary layer meteorology. That is Stefan, another of my PhD students. So COVID was not only bad, it was dramatically bad for most of the globe, and especially some of the regions where I work, Peru, Chile, high mountain Asia, they were hit dramatically, but also put us on this incredible new avenue of research. And I hope, hopefully with the help of SPI, that we will be able to solve the Karakorum Permia anomaly. Definitely not as alone as a group, that also foster an incredible interdisciplinary work. So in the end, it was quite good for us. And with this, I thank you very much for your attention.
Our next speaker is Loïc Pellissier, both affiliated to EPFL and VSL, and I invite Lynne Chandler to get ready.
Thank you. So together with me is Melissa Jacquier. So you can see here a very nice picture of one of the field sites where we collected samples. But actually myself, I did not participate to any of the mission. So Melissa will explain a bit more after because she was in the field. So together with the SPI, we had 2 sampling missions last summer. And in our group, we are developing methods to better monitor biodiversity. And my first mission in the Arctic was actually in 2012, and it was still with very traditional methods. So it's kind of a very long time-consuming to collect information about species in the field. But what we are developing now is new method based on environmental DNA to target plants and animals directly from sample of the environment. So we can collect water. For example, here we can collect water in a fjord, a large volume of water, hundreds of liters, and then we can amplify the DNA that is found in this water, and then we can detect the organisms. We can detect both microorganisms, but also whales, fishes, sharks, and all the different organisms that you're interested in. So what is really interesting with this technology is that it's very easy to apply it in the field, and very fast, so we can set up time series. And we applied this technology in Norway, and Svalbard and Greenland, but also in the Arctic Sentry expedition in Russia.
Yes. So I was lucky to participate to the Arctic Sentry expedition this summer and to collect more than 50 eDNA samples and also approximately 20 microplastic samples. So you can see the extent of the sampling at the bottom right of the image. So not only thanks to the extent of the expeditions, we were able to collect such a widespread data set in the Russian Arctic, but also we were able to collect at a great range of depth, so ranging from the surface to more than 2,000 meter depth. And as you can imagine, it's not easy to get data from fish at 2,000 meter. And traditional methods have been diving, and I would not have been happy to dive for 5 weeks there. Yeah, I'm very much looking forward to present you the results that we got there. Thank you.
I invite Lynne Chandler from the University of Lausanne. And I asked Surya Narayan to get ready, please.
So thank you. So I will focus today on two projects that I led with a different colleague in Nunavik. And because, as you know, for the last 2 years, I didn't have the chance to go to Nunavik, I will mostly focus not on the result of the research, but on the outreach that we are developing with my colleague toward the local population. So the first project that I will speak about is the Nuna project. It's a project that I led with mainly two other researchers, Fabienne Joliette from France, and she's linked to IPEV, and Thora Hermann, she's a German researcher. This project, the Nuna project, is developed inside the Human Environment Observatory. It's an observatory that is built by France, the Centre d'études nordiques from Laval University, and with a local researcher from Nunavik, northern Quebec, the Makivik Society, and the regional government of Kativik in Nunavik. And so in this project, we are focusing on the relationship between people, the land, and the different beings from the land. It could be spiritual being, the animal, or other vegetation, for example. And in this project, I'm involved in it since 2016, and we did some participatory video with a local school. And with the local school, we work with the youth, and the youth, they go on the land, and they did some very short video, and they interview their elder and stuff like that about what Nuna means to them. Nuna is the word in Inuktitut, who means landscape or territory. So in this project, because we collect for the moment 4 different videos from the local school, we work, for example, this year on an interactive map. So you have a snapshot of the map where we try to emphasize the interviews that the youth did with their elder, and in this interactive map we want to share it with the local school, because the Scholar Commission from Nunavik is really interested to develop some tools to work with their kid, with the kid, about the videos that the kid did on this research project. So this year we work on this tool, and we will share this tool with the local school and with the teacher. Like this, they can use it in their program with the kid. And this interactive mapping is done for Nunavik, but we try to network with some Greenlandic project as well, and with another project with Sami Land, because the Sami are doing the same kind of work, and we try to develop an interactive mapping with them as well. So it is the first project that we are working on. The second project that I'm working on is Indigenous People, Dog and Wellness. It's a project that we are leading with the University of Montreal and the Veterinary Department. It's a project about dog and how dogs are involved in with the local inhabitant. There is some health issue with the dog because there is some rabies outbreak in a local community in Nunavik. But the dogs are also very important for the culture and for the well-being of the people there. So in this project, we did a lot of different interviews with local people to know better how what is the relationship with the dog nowadays, because most of the dogs in Nunavik are not used to a sled dog anymore. They are more used like a companionship or like other cohabitants inside the community. And in this project, because we didn't have the chance to go back on the field right now, we are just working on collaboration to develop outreach with the local inhabitant. And for example, the community members are very interested about to have a better understanding about first aid and veterinary services, because there is no veterinary services in the north. And so we are trying to put together, for example, a dog first kit and a guide for the community members to help their dog when for example, a car hits them or if they are injured. So we are working with the local community and the inhabitant to know exactly what kind of questions they have about their dog and what are the answers that we can bring them or help them better to have a better relationship with their dog if they are injured. Thank you.
So now it's the turn. I'm sorry, I'm going to read this one. It's a bit complicated for me. Suriyana Rayanan Balasubramanian from the University of Fribourg. And I invite Elena Plikanova for next turn.
Hello, everyone. So, for centuries, local cultures in the Himalayan mountain ranges have believed that glaciers are alive. What's more, glaciers have gender, including male and female. These people breed new glaciers by grafting together or even marrying ice fragments from male and female glaciers. Yeah. Ice fragments from male and female glaciers and covering them with charcoal, willow branches so that they can reproduce in privacy. These glacierets later transform into fully active glaciers that grow each year with additional snowfall. These practices have inspired other cultures to make their own ice reservoirs and apply them on modern problems surrounding water supplies. Take Ladakh, a high-altitude mountain desert in northern India. This sits in the rain shadow of the Himalayas, receiving less than 10 centimeters of rain or snow per year. As glaciers decline due to climate change, regional water scarcity is increasing. So people here have taken to these ice reservoirs as insurance against this uncertainty. Just last winter, around 40 ice stupas, as they are locally called, were built by communities. Around 40 different villages, local farmers from 40 different villages built these structures. And that shows how easy and cheap they are to build. A typical ice stupa just requires a fountain nozzle and a supply pipeline. Due to the altitude difference between the water source is a glacial lake or a glacial stream, and due to the altitude difference between the pipeline input and the fountain output, droplets freeze in the ambient air and accumulate as ice below the fountain. These fountains are manually operated during the winter nights, and they are raised by addition of metal pipes as ice builds up under them. I have been building these ice stupas since 2015. But whenever we build a new ice stupa in a new location, we never know what to expect. Will this ice stupa grow big enough to break our old records, or will it not even last in the heat of the next day? I have often wondered, are ice stupas the best way to achieve such winter water storage? Watching these ice stupas grow in the winter, I wondered whether the water we spray is actually freezing or ending up in a puddle somewhere. Watching the ice stupa melt under the summer sun, I wondered whether the water we froze was going back into the atmosphere as through sublimation or evaporation. These were the questions I brought with me when I joined my PhD program in University of Fribourg. Under the team of Martin Holsley, we developed a new measurement campaign around ice stupas using drones, weather stations, and flow meters. We deployed around 5 weather stations in the region of Ladakh and used drones to manually to find out the ice volumes, the temporal evolution of ice volumes. Today I will be with the support of the Polar Access Fund, we were able to deploy this measurement campaign simultaneously for ice stupas in Switzerland and in Ladakh. And what we found really surprised us. We saw stark differences in growth rates between the ice stupas in India and Switzerland. The Indian ice stupas had achieved ice volumes around 5 times larger than the Swiss ice stupas. The sublimation and evaporation losses were negligible, but the associated energy losses were quite significant. In fact, due to the freezing energy generated by the sublimation process, the Indian ice stupa was able to grow much larger and last much longer compared to the Swiss ice stupa. But both the ice stupas suffered significant water losses in the order of around 80% of the fountain water input. These findings will now help us increase the storage efficiency of existing ice stupa construction locations, and also to identify other locations where these ice structures can serve as to achieve winter water storage. Thank you.
So now it's the turn for Elena Plikanova from the University of Zurich, and I invite Christophe Randin to get ready for next turn.
Hello everybody. Today I want to present an update from the field work that I have done this year and our team have done this year. So our research station Kitavik, where we work, is located on the very north and very east of Siberia, and there is a tundra area there, so it is very flat landscapes with shrubs, mosses, a bit of grasses. And what we study there, we study how does this vegetation change and how does it influence the permafrost that is below. So here I would like to concentrate on the 2 points of our research, and the first one is the train experiment. So this is a precipitation experiment that we established 3 years ago, and it consists of 10 blocks distributed across different vegetation types, and each of block have 3 plots. So here we have like the small models of them. So one of these is like increased precipitation plot, and this is increased precipitation scenario is what we expect in the future over those areas. That is plus 50% of the precipitation. And reduced precipitation, the shelter where we reduce half of the precipitation that's falling down. So we experimentally model those scenarios that will come into the future in the regards of precipitation. The challenge there is that the treatment is relative, so we add plus 50% of what is fallen and minus 50%. So last 2 years were quite dry, and as you can imagine, a few precipitation minus 50% and few precipitation plus 50% doesn't make a lot of difference. So we haven't observed big changes in the soil moisture underneath those plots. And this year, as you see on the picture, there were some rains, and this is like our first success that I want to share with you. And the second story is about the drones that we fly there. So we fly drones to monitor vegetation of those areas throughout the years. And before going to the field this summer, we sat together with my supervisor, Gabriela, and planned where to fly the drone. And then she told me, Elena, this year, please don't crash the drone. So the story is that Gabriela wanted to bring it to the Arctic Sentry expedition that was upcoming, and I was actually operating it 2 years before, and last year there had been some problems with engines, and the year before there were some problems with wings. At the end of my fieldwork season, the drone was not working. So this year I flew very carefully, selecting the good days, not the rainy days as you see on the picture, and I didn't crash the drone. So that is the second success of this fieldwork, and then Gabriela was able to bring this drone to the Arctic Sentry expedition to go to the island, to fly it, and to crash it the first time. No. But she was so thoughtful to bring another drone on the ship, so they were able to map the vegetation on all the islands that they have been landing. Thank you very much for your attention. This is all from my side.
Thank you, Elena. You should bring your instruments at the apéro. I think you're going to have a great success. And now it's the turn of Christophe Randin. He was supposed to be with Sabine today. Sorry. He was supposed to be with Sabine today, but we have to excuse us and hope that she gets better soon and join us for our next event. And I invite Daniel McGuinness to join us after.
So good afternoon, everyone. So I am one of the PIs of the Summiter project. Yes, sure. Together with Sabine Rumpf from University of Basel in the left, and Stari Einmarsen in the front. And this project aimed at resurveying permanent vegetation plots that have been established in 2008 on summits in Iceland and in Greenland. And you might wonder, so what are these botanists looking at on the screes up there in Greenland? Actually, there are more than 40 vascular plants in the screes, and there will be more and more because of climate warming, and this is why we were there this summer. And other reasons to look at alpine vegetation, so it's super rich, so it's more than 50% of the biodiversity hotspots in the world. We are 3 times richer than the rest of the continents, and alpine vegetation is the only vegetation type that offers a full continuum from the equator to the pole. And also, interestingly, so this vegetation type is defined by the tree line and the shrubs, and taller species are currently invading the alpine vegetation zone. And as you can see on this graph, on this synthesis, there is an increase of biodiversity in the alpine zone, and this rate is also increasing with clear tipping point over the last 3 decades. So alpine vegetation zone are sentinel of climate change because they react very quickly, but there is a need for standardized monitoring technique, and this is why the Gloria initiative has been designed. It is composed of 130 sites around the world on 5 or 6 continents, depending on how you count, and each of the sites is composed on 4 summits from the low alpine to the limit of the naval zone, to the limit of the cryosphere. And we focused on these 2 sites, so near Akureyri, so in the subarctic, 64 degrees, and Zackenberg on the east side of Greenland. And we measured the response of diversity, so species, biodiversity, species abundance, on each of the aspect of 4 summits on each of the sites, And we also measure the drivers of the changes in biodiversity. So soil temperature, so the abiotic factors. We also made some soil profile. We performed some soil analysis, and some people who are in the room, Konstantin Gavazov, will also assess the soil microbiome, and people from University of Lausanne will also assess the nutrient cycling, which are also potential drivers of change. So stay tuned for the result. And next year, we will go to Vallis to perform the same design, which will allow comparisons with the Arctic and the subarctic. So thank you for your attention.
Now I will leave the floor to Daniel McGuinness from the University of Geneva, and I invite Peter Gallinelli to get ready. Thank you.
Thank you very much, and thank you for the opportunity to be here and present our research. I'd like to present our program, Arctic Change, Monitoring Greenhouse Gases. This is a collaboration between the University of Geneva and the Foundation Pacific, and my other co-author, Laura Muller, she's the scientific coordinator from the Foundation Pacific. The beautiful blue boat in the background is the Mauritius, owned by the Foundation Pacific. She's a 31-meter schooner, steel hold, and she's on a 5-year mission around the Arctic for various reasons, but from our purpose to collect important data. The goal is to use her as a floating laboratory, and the data we're collecting is atmospheric water column, methane and CO2, surface water temperature, and salinity and dissolved oxygen from the surface waters. So our goals, our outcomes are for public outreach, to interact with the communities, to refine and improve the budgets of methane and carbon dioxide in these regions, identify important hotspots of methane degassing, as well as educational opportunities. So currently, I teach this as well as the data in our course, as well as supports master's and PhD students. We have 3 master's students here, as well as our PhD student, Cesar Ordonez, who just won or was awarded the Polar Access Grant from the SPI, who will go next year. Well, as I said, we're on our third year of her mission, starting next year. She started from France last year and went up to Tromsø, and this year she left Iceland and went around the south of Greenland and is overwintering here. And next year, she's heading on towards Cambridge Bay in Alaska. So I was actually really happy to see Martin's talk here, so we can discuss this later. Then finally, she'll overwinter in Anchorage and then along the Russian coast, and then overwintering there, and then ending up back home at the end of 2024. Just briefly, the data we collect are methane, so we continuously measure methane and CO2 in the atmosphere, as well as water samples, which are sent back to the University of Geneva for analysis. And we have installed a moon pool in the aft of the ship that measures where we install the sonde to measure the oxygen temperature, et cetera. The important thing in this mission is that the methane and CO2 balances are very unknown, and we know that the Arctic waters are an important region for uptake of CO2. However, these maps are based on very few data, and there aren't no satellite data for these gases over water. So we need on-the-ground data to really improve and understand how these fluxes are changing in this important region. I won't go into the numbers here. So this is a low-cost platform, green. It's not completely green, but relative to large ocean-going expeditions, it's a relatively green option for coastal oceanography. We want to use this as a proof of concept that other boats will start collecting similar data. These are very easily obtained samples, and Peter will actually discuss that right after me. And such a boat allows entering very near coast regions and fjords where larger vessels can't access to collect these data. And then finally, I wanted to mention that she's overwintering now in Disco Bay, and I think, if I understand Laura correct, there might be some opportunities for overwinter stays. If anybody may be interested, contact her for that during the apéro. So with that, thank you for your attention.
So now it's Peter Gallinelli's turn from the HES-SO Geneva. And I invite Alan Alpenfeld to get ready, maybe come closer for his turn.
Okay, thank you. So actually I will be talking about another floating laboratory. As you can see, small vessels get into the business also. And well, I'd just like to point out some of the field work that was done, that is being done on work. So just to give you an idea how things can operate on a very, very small scale. Actually, the sailboat you see is a Swiss boat, which is operated by a Geneva-based non-profit organization. Well, what you see here is a typical program of a 4-week expedition. This was done in 2020. Something very similar was done this year. So it's the whole voyage starting from a place like Norway or Iceland or France or some easily accessible place, Europe, sailing to the Arctic. This is Blossville coast, and then back and taking many measures. There's some very simple things that can be done during the journey, just as measuring temperatures. There can be other sensors, of course, but these are very easy to deploy, and it's knowledge that can be produced in a very cheap and easy way. So just think, when you travel to a place, take advantage of making measurements. Here, temperatures that can show evolution in the surface temperatures. These are very interesting topics, and this information, if it's made available as open source to the scientific community, is something very interesting. These are examples of field work. This is in Nansen Fjord. These are taking methane and CO2 samples. Danielle has just presented the work. Actually, this is going on in parallel on what is happening in the Mauritius. And doing this kind of work on many small boats is a very nice thing, to do things in parallel and not going just to one place, do something, then come back and do something else in another place. Other things that were already pointed out, using commercial low-cost drones is a very interesting feature, such as documenting in a very good resolution information, visual data, building 3D models. For example, here we have a 3D model of a glacier front with about centimeter resolution, which is very interesting just to make a time snap of what it was like at some times. And other crews can come back in 2 years, 5 years, 10 years, redo the same things, and there can be very interesting things to be observed and discovered. Other things, this is interesting to point out, diving is always a challenge in the Arctic due to the very severe conditions. We opted for free diving because it means there's a very small amount of equipment, and it's much safer also. Actually, you don't go very far, but it's very useful to take samples on the ground or fjords or in lakes, and do it in a very lightweight and easy way. So, part of the question this morning was about environmental impact while doing environmental studies. I believe it's important to question yourself, if we do environmental studies, can we support in polluting the environment? You cannot do it without anything, but you do need a minimum, and I think these kinds of going to the Arctic are very interesting and probably will be promoted in the future. It means perhaps we cannot do it without traditional ways, but there's a lot that can be done using wind power, using solar power, and even more so using efficient systems. So efficient system would be, for example, passive design for this boat that stayed over winter in the very northern part of Greenland with very good comfort and using close to no energy, and without polluting the local environment due to gensets, heating systems, and so on. So I think there's some complementarity. We already saw the Astrolab on one side. Well, we have another kind of vessel on the others. Of course, they don't do the same thing. I would say on one side we have the Himalayan style, which is going with heavy equipment, with big budgets, with a lot of planning, and kind of things that have been foreseen very far ahead. On the other side, you can think about the Alpine style. It really means going lightweight, going fast, going on opportunities. Perhaps you don't have the 100% guarantee of success, but you have the opportunity to go to many places, to different places. And I say it's not replacing the old way of doing, but rather opening new ways of doing things and taking into account ecological aspects, financial aspects also, because this means you can go more often to more places and over longer periods. Okay, well, of course, tools have to be designed for this. This is especially this sailboat. It's designed in this way. It sounds quite logical. Well, real life looks rather like this. It's not 30 centimeter ice, but it's 3 meter ice, so things have to be very sturdy, and this is true also for all the scientific equipment on board, especially of small boats. It has to be thoroughly designed. What works perfectly in a lab on land is not guaranteed to work in the field, so it needs some preparation. I think this is something specific to think about, and when I was talking about engineering development, it's something like this. So thank you very much for allowing me to speak, and well, hopefully I'll be available to discuss during the aperitif later. Thank you.
And our last speaker, Mr. Alan Alpenfeld.
So, last but not least, I hope. Yeah, as you see, there's nothing under my name, and that's because I'm not a scientist, I'm an artist. So I just kind of came in here because basically for my next project, I'm looking for 3 to 4 scientists and projects. And 2 years ago, there was an open call called Polar's Open Call by Pro Helvetia. And I participated with a project, but it didn't happen. And basically, I was supposed to have work with a tandem, but I couldn't meet the various scientists because I was on another project. And so I proposed to Pro Helvetia to follow all the scientists with a project, which I'll tell you about. Unfortunately, then the fundings arrived late. The scientists and the artists they moved their schedules down for COVID and stuff, and it didn't really happen. So I'm still looking for these 4 scientists who work in polar regions and extreme regions. Oh, that's the one before. Right. So this is Mawson Hut in Antarctica in 1967. And it's a radio made by Chris Simpson called Radio Blitz. And basically it was made to broadcast some music to scientists while they were working there. Now I'm an artist, I'm a theater director, and I also work with radio. And the project is called Observing the Observing Observer. So myself, Alan, Olga Kokcharova, who's a sound artist, and Alfio Tommasini, who's a photographer, we intend to follow 4 scientists to their extreme places and observe you while you're observing whatever you're observing and doing. And that's because we are incredibly fascinated by what you do. And so we have myself and Olga, and this is Olga. Now, I don't know if you can see her, but she's in the dark. And Olga, she's a Russian-Swiss sound artist, and she's basically recording trees while they're drinking during the night. And she's made a sound installation about this, and she's very, very interested in what scientists do, and she records their sounds. Everything you create, you do underwater, all the sounds that you do with your work. And she creates these incredible sound installations. And Alfio, okay, that's not Alfio, but that's one of his photographs of his last work. And it's a work about the production of milk in Ticino. And so we would like to come with some of you to where you go for brief periods. And I know that your work is very delicate, so through dialogue with you, we would understand when we could come, and we'd like to just simply observe you and record what you're doing. We will create 4 radio stations in these extreme environments, and we will broadcast the work to 4 listening spaces here in Switzerland. We will then create an art book about the sounds that are created and the photographs of the observers of the observers. So basically, Alfio is the observer who observes me and Olga, who observes you. And ultimately, we have the public who observe Alfio's work, who observe me and Olga, who observe you. So I'll just conclude there. I would love to meet some of you. If anybody's interested in collaborating with me, let me know. This work will also become a radio drama and eventually also an exhibition here in Switzerland. So that's about it. Thank you for the space.
Thank you very much, Alan. And maybe this is also a case for a PolArts project later this year, so you can always stay in touch. And now we would like to actually close this day, and maybe you want to come, Gabriela. And maybe first, I just want to say a big thank you to all of you. It's been just an amazing pleasure just to see, talk again, and catch up on the lost opportunities of the last years. So see you soon again.
Just a word maybe
Well,
for the speakers. For the speakers, if you want your graph short, a little gifts for you, so you can pass by me before the aperitif, and I can give you a gift. Thank you.
What a day, isn't it? We heard so much, we had so much information coming in new. I always think I know polar research in Switzerland quite well, and here we go with ice stupas and arts projects and whatever. Too much to absorb right now. We probably all have to digest a little bit now, and I will not say anything more. I'll just really invite you to join for the apéro, enjoy, and we really very much hope to see you again very soon at some of the events, and otherwise, of course, definitely next year again at the Swiss Polar Day 2022. Thank you very much.